I'm going to break this exercise into two parts, and the first part is the introduction to substitution technique. Let's begin with this example. You probably recall there is a formula for us to integrate this function. And plus c, and the outcome of the integration would be power of 3 6 here. I'm going to try to integrate this again with a different approach by using a substitution technique. And what we're going to do is we're going to define a variable. We usually call this a dummy variable because, well, we're just going to use u temporary, and after that we get what we want. So u with 2x plus 1. The reason we choose 2x plus 1 because the problem actually, you see the problem would be very easy if we have something like this, right? But not in this case. Although we have the formula, but suppose you do not know the formula and you get this. And so if we can change the problem to look something like this, x squared, it will be easy for us to perform the integration. So we choose 2x plus 1 and derive this or differentiate with respect to x, get 2. That means half du is equivalent to dx. So what we're going to do now is we're going to perform the process of substitution, and this expression here is actually u, as you can see, square, and dx is actually half du, and so we'll have half. Remember, you can write the number in front, the scalar in front. So you have u squared du, and this immediately becomes, we transform the problem to look something like this, and we can perform the integration. This is u cubed over 3 plus c is u cubed 6 plus c, but you can't end like this. You can stop here. You have to then replace u with 2x plus 1 because that is actually our original problem. You see, you get the same answer as when you use the formula. Now move on to question from the exercise, and start with this. We have this expression. Wow, it seems very, very complex, isn't it? And not when we perform the substitution. So we're going to let u be one of these expressions, but the problem is which one. Now if you think about it and observe carefully, you realize that the x cubed plus 1 is actually the antiderivative of 3x squared. So we're going to replace this guy here. We choose the antiderivative and derive, differentiate it. I mean, get 3x squared. So that means du is equivalent to 3x squared dx. Alright, and our task is actually to integrate this. So we're gonna switch the position for a very good reason. Tell you why later. You see why later. I group this, and now this is actually u. Right? It's our choice to let this be u. So we replace that, or substitute that rather. This is 3x squared dx. Where do we see that? Okay, so this is actually du. Replace this whole thing with du, and now becomes suddenly this becomes a very simple problem. U power 5 or u plus c. Of course, we do not leave the answer as follow, and we will replace u with x cubed plus 1 power 4 or 5, or should be 5 here, plus c. Alright, isn't it? I mean, if you can check by differentiating this function and see whether you get this back. Okay, I want to do move on to one of the other questions. 2 here. Do a part B, and we have this problem. Actually, if you're skillful enough, you can actually just write the answer. I know the answer is actually ex squared plus c, but how do I know that? Okay, it's like this. Now we know that the problem is easy if we have something like this, something like ex dx. This is very easy, and the answer to this is ex plus c. Okay, so what if we can change or transform this problem to look something like this? Okay, now we then by choice we let u. Okay, remember that I know the answer, but I want to show you how we actually can do this by using substitution technique. Let u be x squared. And so now du dx will be 2x, and we always like to collect the x term, or the x with dx. Okay, now we have this. Now do you see something there? There's a pattern here. Now you see 2x dx, and you have the 2x dx. Now I keep calm, right? Do this dx. Now we perform the substitution process, but before that, let us swap them, or switch position. And again, I put the brackets to indicate we are grouping them, and okay, and now perform this substitution. This is u, remember, and this is actually du right here, and this is u, and it's like just like magic, you get a problem like this. And we know that integrating ex is ex plus c, but now we have u, so it's just eu plus c. However, what is u? U is actually x squared. You just replaced it, and voila, there you have it, the solution to this integration.